Okay, thank you very much, Simon. Good afternoon, everybody. I missed the start of this session today. I missed this morning, so apologies for not being here earlier. Unfortunately, my new school walking robot wasn't fully charged, and I had to take the kids to school myself. Maybe that's one way that digitalisation can help to deliver decarbonisation of the energy system by making us on time for work. Hopefully, I can make you think of some other ways it might help. Firstly, in my presentation, I want to introduce a vision of what digitalisation means. Hopefully, this accords with the previous speakers' descriptions and assumptions. The world of business is about taking decisions based on information and then executing those decisions. Digitalisation, perhaps ironically, is not a binary concept. It is a process. How many people in this room, please put your hands up, if you use a keyboard? Okay. So how many people in this room, put your hands up, if you started work using a keyboard? Not everybody is putting their hands up, and that's because actually the role of a typist was a very specific function in business a number of years ago. When I started in BG Transco, as it was, 20-something years ago, I too had a keyboard and I used a keyboard. I'd been at university doing computer science, so I even had an email address at the time, which was not that common at the time, cs2ap@dmu.ac.uk, if you want to find out some embarrassing facts about musical taste. Anyway, the point is that digitalisation is a process. And 20-odd years ago, the idea that the managers of the organisation would become typists was almost derogatory. It was insubordination to suggest that sort of thing. So we're all typists now. The transformation from being managers to being typists has not happened overnight. This is digitalisation at work. However, the pace of change has increased, especially over the last few years, and this is leading to some very significant impacts about the way we think about the world. 5G communications, cheap sensor data, the ability to interact with individuals, I'll come back to that, GIS services, geolocation capabilities and GPS, drones to access real-time information, ERP systems, mobile apps providing real-time data from users. There is an explosion of new data sources out there. Pöyry has engineers working across this sector. For example, we're using drones for overhead line monitoring. During the construction of civils, we're using 3D imagery data, satellite image data, so on and so forth. I've even been told that we've been using social media data for over 10 years as part of the demand forecasting in the pulp and paper industry. Much more powerful ways of analysing and understanding that data, and a myriad of different machine learning and artificial intelligence algorithms are now commonplace. Data science is now a sexy, well-paid career path. And a lot of this pervades ordinary business, and the understanding that this brings is being made available to the geeky masses, being made available to the less geeky masses, like my first managers in industry, through techniques such as advanced visualization, augmented and virtual reality. Pöyry has experts across this space as well, but digitalisation is also giving us the ability to remotely execute the resulting business decisions, to control devices at much, much smaller level, to execute trades in the market, to order spare parts and schedule maintenance crews. These changes are truly game-changing for many industries. So there is a much broader set of input data feeding automated decision-making and execution. This also drives a much greater focus on security of these systems and of the data, so there is also a growing need to embed cybersecurity within ordinary activities, ordinary business activities, ordinary social activities. But it lowers costs and allows innovation. It allows new market actors to get into the space. It lowers barrier to entry. But this really is all just incremental efficiency gains. It is the continuation of a trend since time immemorial that we, as humans, find easier and cheaper ways of doing the same things. A more revolutionary impact of digitalisation, and I think this is the revelation over the past couple of years, is the ability to deeply, quickly and directly interact with consumers, to unlock often hidden consumer preferences and dynamically respond to customers' needs. Identifying what consumers really want and are prepared to pay for, and tailoring the product offering to fit the there and then of the transaction. But digitalisation also breaks down barriers. We already know that there is the potential to influence politics and to facilitate political change. This may or may not be a good thing. But this same concept extends to disintermediation, cutting out of the middleman, which is leading to some interesting developments such as the concept of peer-to-peer energy trading. This could be revolutionary. But I think beyond this, it is the ability to combine these new methods to deliver new value. For example, combining predictive maintenance techniques that tell us what the physical asset might be capable of doing into the future, combining that with algo trading information that tells us where the market value is in the future, and allowing us to optimise the maintenance against the market and at the same time ensure that the needs of the asset are priced into the market, but doing so automatically. In putting this slide pack together, I relied upon a rather large library of slides that we in Pöyry have for talking about digitalisation with our clients. A big part of our work as management consultants in energy relates to the electricity markets, especially of Europe and North America. And as we all know, in electricity markets, the term energy is often used instead of the word electricity. It is also used in that context to draw a distinction from the word power. These are different concepts in the electricity markets, essentially drawing a distinction between the commodity and the capacity. So, I've clarified with a little sparky icon, the top right, of the slides and the next couple of slides, to make it clear that I'm referring to electricity in these slides. Now, I know it's only part of the energy mix, but it's worthwhile considering electricity in the context of digitalisation, because digitalisation has the potential to have a much bigger impact in electricity than in other forms of energy. Society knows with absolute fact that it can achieve deep decarbonisation by electrifying everything. This is a message to the gas industry. In particular, society knows it can decarbonise heat and transport using electricity. However, the massive amount of electricity demand growth that would ensue would lead to the construction of a massive electricity network and associated generation capacity. Whilst this can be, and already is, somewhat mitigated by the use of the flexibility inherent in the connected demand and generation units, it may not be the cheapest way of decarbonising the economy as a whole to achieve something like the Paris Agreement. However, digitalisation is already providing a very large scope for changing the relationships between electricity customers and the system. Multiple suppliers and aggregators at one meter point, moving away from energy-based charging, reflecting sector coupling-based services, and individual device control. This graphic is not real. This is a bit of a thought experiment, this slide. Imagine a washing machine. Imagine that Amazon bundle the electricity with the device. It could also be the manufacturer. Imagine that they sell you a standard energy bundle. All the washing you could handle, which incidentally is quite a lot if your school walking robot has a tendency to walk home from school via a muddy playground. But also imagine that they sell you a cheaper package of electricity if you relinquish some control over the device. Now, rather than taking 1 hour to wash your clothes, it takes 2 hours, 4 hours, or potentially overnight. And Amazon or Hotpoint get to choose when the water is heated and when the motor spins. Whoever or whatever, it is likely to be bundled with other value-adding services. Maybe the electricity is bundled with the device for free if you've got Amazon Prime Gold status because you've binged-watched 4 box sets last month. Or perhaps you buy a new electric vehicle from Jeff Bezos' favourite car manufacturer. Fun fact, by the way, Jeff Bezos actually drives around in 1996 Honda Accord, and he leaves his $4.5 million Lamborghini at home. Whilst doing some research for a client last year, I came across a company called Carnival Cruises. They sell cruise holiday packages. By using social media data, they profile individual website visitors and dynamically alter that website user's browsing experience, tailoring the cruise package that browser sees and dynamically altering the prices. Now, the cruise line operator is interested in the total revenue and profit that they can get from having that passenger on board. And there are different price points along that journey, and so the cruise operator, by using the social media data, has an understanding about whether that particular user wants to pay more for their cruise and less for the trinkets and meals when they're on board, or the other way round. But they do that across the population of people who are going on that particular cruise that gets booked. So they're dynamically altering the user experience in the booking process to extract value from that consumer. So the ability for the retail end of this to really change the way that consumers interact with energy shouldn't be underestimated. But electricity on its own is not energy. Industry, transport and heat also need to decarbonise. The little chart here shows the scale of the problem, and this is assuming that we have a 95% reduction in CO2 equivalent across Europe by 2050. Europe probably has to lead in the Paris Agreement in achieving the 2-degree cap, or the 1.5-degree cap, which looks increasingly unlikely. So Europe has to decarbonise much more, or very severely like this. The energy sector, defined here as power, heat and transport, accounts for roughly 3/4 of that 95% reduction. The transporter sector alone emitted almost 3 times the total 2050 European limit in 1990. These sectors are difficult to decarbonise, and the residual amount needs to be left there for the very difficult to decarbonise sectors such as agriculture and industrial processes. Achieving such a deep level of decarbonisation is hard. Our decarbonisation study, which was released last year, it started out a couple of years ago, it started out being called the future role of gas. similar to many other studies that were done and have been done over the last couple of years. And similar to these other studies, it showed that full electrification is significantly more expensive than alternatives that make use of some of the existing gas network assets. We concluded that steam methane reformation with CCS was probably the most cost-effective outcome. We would continue to produce and transmit natural gas as a society and then convert it to hydrogen for distribution, building a new CCS infrastructure to send the bad bits back to geological storage. I acknowledge it may not be sensible to do this everywhere. Estonia and Finland, for example, perhaps Ireland, but it does look to be substantially significant vector for Europe and perhaps, probably, cheaper than electrolysis to produce hydrogen. But in all of this, no doubt, digitalisation will play its part. I think there's two ways in which digitalisation can be thought of in helping to deliver this part of the decarbonisation effort. Firstly, the decarbonisation of industry at large can be helped through the obvious role that digitalisation has in minimising fuel use, maximising asset usefulness, and minimising costs. The concept of accommodating decarbonisation in this sense is that decisions can be made that fully integrate the greenhouse gas impact of the industry. For example, if we cannot greatly decarbonise steel production, perhaps building architects need to specify the use of aluminium instead, smelted using renewable electricity instead of using steel, which has the carbon input into it necessary as part of its substance. These four elements, I think, help to ensure that we minimise waste and we integrate decarbonisation and environmental thinking into business decisions. But the second part of this is that digitalisation, embedded within the development of technologies like SMR and CCS, will lower the costs of delivering them and therefore enable us to maximise the benefits derived from them. But even if the green lobby accept that SMR and CCS has a genuine place at the downstream decarbonised energy table, the green lobby still has a massive problem with one of the skeletons in the gas industry's closet, methane venting and leakage. Digitalisation probably has a massive amount to offer in this space, but it will not be pushed by the tech sector and it will not be pulled by the consumer. It has to be driven by the gas industry. The Paris Agreement doesn't require Russia, Iran or Qatar to report their methane emissions. Noting that methane is 7 to 100 times more potent than CO2, and the US is withdrawing from the Paris Agreement, Russia, Iran, Qatar, US are all massive gas producers. If the EU's satellite-based global methane leakage survey shows that the Russians, etc., are telling the truth in what they are reporting, then maybe the green lobby will accept that a small amount of methane leakage is okay. But I doubt that Greta Thunberg will. The European gas industry needs to ensure accurate, audited, and certified methane leakage rates throughout its value chain. Perhaps perhaps there's a blockchain solution to fit that. Just to finish my presentation, obviously I've got to try and sell Pöyry because I'm standing up here at a conference and I'm a consultant, and that's what we do. I mentioned that we did a decarbonisation study a couple of years ago. We've done some additional work on top of that, on the basis of that, for some clients, so we're capable of doing that. Our energy modelling suite is really, it goes into an awful lot of detail. It goes down to hourly or half-hourly granularity, and it goes out to 2060, and it integrates all of the various different energy markets together as kind of a whole system solution. They are individual models. It's not doing a full co-optimisation, but they are iteratively operated. I'm personally passionate about biogas and the role that biomethane will have into the future. I think it's absolutely vital that we get as much biomethane into the gas network as we possibly can, as we sustainably can, over the next 10 years or so. And Pöyry also offers a range of digitalisation services as well. That's my presentation. Thank you very much.
Time for questions. There's a microphone going around the room. Maxine.
You mentioned a passion about biomethane, which I share as a way of doing something in the short term. How can digitalisation help with that?
Is this on?
Yes.
I haven't particularly thought about the application of digitalisation to biomethane. I think there's probably an awful lot of ways that it could help, but they are the standard ways where digitalisation is going to help just general process-based industries and business management side of things. I think there's a lot of work still to be done to understand the sustainability of feedstocks into the biomethane and biogas process. And I was given I had an interesting chat last week at Energy Island with somebody who pointed out that the nitrogen-based fertilisers that they're using in agriculture in Ireland at the moment are causing some nitrogen pollution, and that's really bad from a greenhouse gas perspective. And it's something that we don't really think about. We don't really think about that whole environmental system very much. So I think there's probably some work to be done around that, which would also help. But the biomethane that we produce needs to be sustainably produced. Otherwise, we're just going to end up causing more problems.
So please join me in thanking Angus for his presentation.